Let's, this will be the answer key for completing the square in line through 3 points. I'm going to just go through one of each question type to make sure that we're getting this. For number 1, we want to start with the graph of y equals x squared and then transform it into the graph y equals 1/2 x minus 5 squared plus 2. And I want to do that one step at a time. So I'm just going to do it with only a few points in each parabola. Y equals x squared is a very easy equation to graph. It's just all of our squared values. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on, and then it's symmetrical. So this is our parent function. It's the most simplified version of this graph. And instead of memorizing a bunch of different graphs, you just have to memorize the one parent function, and then you can transform it into any graph that you want. All right, the first transformation I'm going to do on it is apply that vertical compression. We're going to vertically compress it by a factor of 1/2. So now I'm going to graph this in green. To get this one, I just want to take 1/2 of the height of all of these points. And 1/2 of 9 is 4.5. Right, like that. Okay. So here's what our parabola looks like after it's been vertically compressed by a factor of 1/2. Each point is 1/2 as tall as our parent function. All right, the next parabola, I'll apply that horizontal shift. Let me just do shift it to the right 5. So that's going to look like this. And then in purple, I'll shift it up 2. So that's a vertical shift up 2. And this purple graph is our final answer, where we've applied all of our transformations. So there's that 2, 4.50. And all the other graphs were just intermediate steps in getting there. Now, I know this looks a little bit messy. If we are graphing with transformations, generally we erase those previous graphs. But I want you to keep them on there for this homework because I ask you specifically to show each transformation as a step. All right, so purple one is final answer. I'll write that right here, final graph. All right, find the value that completes the square and rewrite as a perfect square. This is like what we would do sort of in the scratch work when we go into these harder problems. So we're not subtracting away that final number, we're just going to write it in there. So to write this as a perfect square, I need to write this as a binomial squared. This number here is always 1/2 of that number there. So this is going to be a +9. And that gives us an extra, if I actually expand this out, n plus 9 times n plus 9, we get n squared plus 9n plus 9n plus 81. If I FOIL that, we get n squared plus 18n plus 81. This question here is just asking you to fill in that 81. All right. Convert all of the following to vertex form by completing the square. I'll do number 4 and 6. To do number 4, what I do is what I did above. I just kind of switch it into this form here, a binomial squared. This value here is always 1/2 of that. But then I still have this plus 14, plus I need to get rid of my extra. And what is the extra? Well, let's do a little scratch work to figure that out. X plus 4 times x plus 4. It's going to get us x squared plus 8x plus 16. So we got to subtract away a 16 to get rid of our extra. gives us a final answer of y equals x plus 4 squared minus 2. Let me actually do number 7. 7's got a fractional a value. That might present some new challenges. So in number 7, I want to get this to be an a value of 1, so I use a technique where I store that 1/2 on the other side of the equation. To get rid of this 1/2, I can multiply it by 2. 1/2 times 2 equals 1, so this is going to get our a value to be 1, but I have to do that to every single term. Now I get a 2y equals x squared minus 8x plus 8. Now I can complete the square on this side. I get x minus 4. It's always half of that b value. Keep the plus 8, and then we'll subtract away 16 because our extra is always going to be this value squared. So we always have to subtract away this value squared. That's kind of a shortcut. I still want to see the scratch work so that on your paper so that I know where that minus 16 is coming from. Combine our like terms here. We get a minus 8. And now we got to send that 2 back. But I'm going to do it with multiplication. I'm going to multiply by 1/2. And that way, our a value actually stays the same. It was 1/2 at the beginning. It's 1/2 here. Final answer, y equals 1/2 x minus 4 squared minus 4. All right. What's great about this, I can tell where the vertex is. I can tell kind of the shape of it based off that a value. I'll graph number 11 here. So convert this to vertex form. We'll get x minus 3 squared. Keep that plus 11. Subtract a 9 because when we square that negative 3, we get a positive 9 extra. Y equals x minus 3 squared plus 2. Put a vertex at 3, 2. And then we go up by that pattern 1, 4, 9. So up 1 from the vertex. Up 4 from the vertex, going out from the vertex and connect up our points. We've got a parabola. All right. Here we want to use systems of equations and a matrix in the calculator to find the equation of a parabola that will pass through the 3 given points. Write the equation of the matrix that you entered in the calculator to show your work. So at the end of class, I kind of gave you a shortcut here where we could use x sub 1 squared, x sub 1, 1, y sub 1 as the values and our vertex, and the pattern repeats. X sub 2 squared, x sub 3 squared, x sub 2, x sub 3, 1, 1, y sub 2, y sub 3. What that's going to look like, when I plug in those values, it's going to be 9, 3, 1, 20. That's x sub 1 there. This is going to be negative 1. No, wait. Made a mistake. X sub 2 is this negative 1. When I square that, it becomes a positive 1. Then we got a negative 1, positive 1, and negative 4. Then we got positive 25 for that, negative 5 squared, negative 5, 1, and 4. Let's do reduced row echelon form in the calculator. I will show this for this one problem with my on-screen calculator. Second, x to the negative 1 to bring up matrices. Scroll over to edit. Enter. We want a 3 by 4 matrix. So if it's not already, make it one. I got to get this matrix in there. We got 9, 3, 1, 20, 1, negative 1, 1, negative 4, and 25, negative 5, 1, 4. Let's just double check that looks right. Yep, all right. That's get out of the matrix, second quit, back into the matrix, second matrix, over to math. Then we want to scroll up to reduced row echelon form. Enter into the matrix one last time, second matrix. We edited matrix A, so we're going to select matrix A. Enter, and we get the values 1, 4, negative 1. So 1, 4, negative 1, let me write that. We're not done yet, though. 1, 4, negative 1, we still have to put that into a quadratic equation. Realize this is an A, B, and C value. So what this is going to look like is y equals 1 x squared plus 4x minus 1. Let me show you a way to double check that. Plug that equation into a y equals. And so we got x squared plus 4x minus 1. Go to the table, second graph, and look and see if it hits those points. It should hit the point negative 1, comma 4. Negative 1, comma 4, there it is. It should hit the point 3, comma 20. 3, comma 20, you can see it right here. Negative 5, comma 4. Yes, it does indeed hit all 3 points. All right, so hopefully that was helpful. I'm going to sign off now. I'll see you in class.